Example 2, we're going to find the value of each missing side length correct to 2 decimal places. We have x and y here. We have an angle, it's a right triangle, and we have a hypotenuse. So if I wanted to solve for x, notice that x is the adjacent to your 20-degree angle. Y is your opposite compared to your 20-degree angle. And then 4 centimeters is your hypotenuse. I always go through and I label my side lengths of my right triangle just to be able to then better set up my SOHCAHTOA. First, I'm going to solve for x, and x is the adjacent side length. I can only use a number that's been given to me so far, and that's my hypotenuse. So if I want to use my adjacent and my hypotenuse in order to solve for x, I'm talking about cosine. Adjacent, hypotenuse, that means it must be cosine. Cosine of 20 equals the adjacent over the hypotenuse. If I wanted to get x by itself, I'm going to multiply both sides by 4. 4 times cosine of 20 equals x. And it says correct to 2 decimal places. So going into my calculator, 4 times cosine of 20, and I get that x equals 3.76. Solving for y, I realize that y is my opposite side length, and I'm going to use my hypotenuse again, always going back. You should always go back to the number that's been given to you. Now we technically have x, right? So you could use tangent and do opposite over adjacent, but that's not intelligent in terms of providing for the human error aspect here. So maybe you got x wrong, and now you're using an incorrect value in order to get another value, so it's going to be incorrect again. Whereas if you use hypotenuse, it'll always give you back, at least you're referencing back to something that you know is correct. Opposite hypotenuse, that means we're using sine. Sine of 20 equals y over 4. 4 times sine of 20 equals y. Y equals 1.37. Next one. We just want to solve for y. We have 15 degrees. I'm going to really quickly label my relationships of those side lengths to the angle I've been given. I'm going to label my hypotenuse first, and then I'm going to label my opposite, and then I know that the leftover is adjacent. I have an opposite. I want to find the hypotenuse. So O and H is going to be sine. Sine of 15. Equals 2 over y. If you are still struggling with having a variable in the denominator, go ahead and put this guy over 1, cross multiply, and then solve. Y times sine of 15 equals 2. Oh, I have to divide both sides by sine, so then I get y equals 2 over sine of 15. To 2 decimal places, 7.73. Okay. So here we were setting up side lengths using sine, cosine, and tangent because we're solving for other side lengths. With example 3, notice that we are now solving for angles. We're still setting up our relationship exactly the same way, just now we're going to be using our inverse values in our calculator in order to solve for the angles. But first, I just need to set up the side lengths exactly the same way I would have set it up with anything else. For instance, looking at this guy with that theta in that angle up there, I have my hypotenuse. The opposite side length is over here, which means that this square root of 2 is my adjacent. So if I have adjacent and I have hypotenuse, I'm going to be using adjacent and hypotenuse together, which would be cosine. Writing that out, it's cosine of the angle. Well, the angle is theta. We don't know what it is. And that equals the square root of 2 over 3. We want to solve for the variable theta. We need to get it out of there. It doesn't mean we divide. It means we need to switch our input and our output. So we are using inverse values here. Cosine to the -1 of, and now you put your side lengths on the inside and it gives you the angle. We just switched our input and our output, and that's it. You go to your calculator, hit the trig button. If you have a TI Inspire, if you have a TI 84, if I remember correctly, they're just like, they're there. The -1 values are the little tiny text above. So if you're looking at the cosine button, it might be blue or it might be yellow text above, and you'll see the -1 there. You just have to hit your second button and then click onto that guy. Square root of 2 divided by 3. So theta equals 61.9. Taking a step back and thinking, does this number make sense in the context of the problem, right? Looking back up here, having numbers that were fairly small made sense because our side lengths were already small. And so we're in that realm of small. If I had gotten something like 1.37 as an angle, I might be a little bit wary. Whereas here, I got 61.9 as an angle, which is like a normal-ish number for a side length or an angle of a right triangle. Whereas if I had gotten it as a side length of a right triangle where the other side lengths were like fairly small, I probably would have been like, I don't know if that's accurate. But reevaluating, looking in the context of the problem, that makes sense to me. That type of reflection is the type of reflection that you should be thinking of and writing down in your IAs. I know a lot of you guys struggled with your IAs and like, where do you write down reflection? Where do you put in your personal voice? That type of idea of like getting a number and saying, this number makes sense because the numbers that were given to me and what we're looking for in this context, like making sure the numbers fit in with the mathematics and evaluating it as we go on. 13 here is the hypotenuse. 12 is your opposite. And adjacent is right there. We have opposite and hypotenuse, so we're going to want to set up sine. Sine of theta equals 12 over 13. Again, we want to switch our input and our output, which is just your inverse. Whoops, no. Okay. We get that theta equals 67.4 degrees. Last problem. Sorry, it's so grainy. Okay, so this guy right here is our opposite. Root 7 is our adjacent. Hypotenuse we don't have. What we do have is our opposite and adjacent, which will lead us to talk about tangent. I was going to skip a few steps and go straight to my inverse, but I will set it up for you. Tangent of theta, you don't have to have parentheses there, equals opposite over adjacent because it's TOA, right? So 8 over the square root of 7. Should you rationalize the denominator? Yes, if it's a final answer. No, if you're still using it and moving forward. Theta equals 71.7 degrees. All right, example 3, done. This is the last thing we're going to talk about for class today, and it's the area of a triangle trigonometry style. So we normally, when I'm asking you to solve for the area of a triangle, you have a triangle where you're like, dun, dun, dun. You have the height and you have the base, and you're like, okay, well, the area is 1/2 times base times height. And the tricky part is we're not always given the base and the height. And so sometimes we're like, okay, well, we're gonna have to go in and we're gonna have to calculate for the height, we're gonna have to calculate for the base. There is another formula. I do believe it's in your formula packet. And that formula helps you find the area of a triangle without having to solve for the height. Now, oops. So let's arrow trig style. As long as you have this information for a triangle, you can find out the area of that triangle without having to find the base or the height. All you have to have are 2 side lengths and the angle between them. Your formula is area of a triangle equals 1/2 AB sine of theta. So it's 1/2 times the side length A times the side length B times sine of that angle that's between the 2 side lengths. So as long as you have 2 side lengths and the angle between them, then you will have enough information to find the area. See, both of these triangles right here have 2 side lengths and the angle between them, so they're setting you up for this wonderful situation. Find the area. I first write down my formula. One half times 6 times 5 times the sine of 30. Just one foul swoop in your calculator, 0.5 times 6 times 5 times sine of 30. And the area is, come on, 7.5 centimeters squared. Go ahead and calculate this guy on your own. All right, that is the answer you should have gotten for your area. And that is it for our notes for today. Good job, guys.